Hi, I'm Ken, I'm a maths tutor, and this is how I teach the nth term of a linear sequence. So a linear sequence is one where it goes up the same each time. This sequence is going up 3 each time. So if we were asked to find the next term, what's going to come after 11, well, we would add on 3 and it would be 14. But the nth term is coming up with a rule for the sequence, a rule that we can use either to find another term or to check if a number is in the sequence. How we do this is, because it's going up in threes, it's the 3 times table. So I wouldn't actually write this each time, but I'm going to write it this time. It's the 3 times table, and the 3 times table goes 3, 6, 9, 12, and our sequence is 1 less than that. 3 take away 1 gives you 2, 6 take away 1 gives you 5, and so on. So our sequence is the 3 times table, subtract 1. So I've written this as a sentence just to make it clear where what's coming next is going to come from. So in maths, we never write things like this. We never write sentences if we can avoid it. So instead of the 3 times table, what we write is 3n. And I'll come back to what n is in a minute. And because we're subtracting 1, 3n minus 1. So that'll be the rule for the sequence, also known as the nth term. So what is n? N is like the term of the sequence. If it's the 5th term of the sequence, then n is 5. If it's the 12th term of the sequence, then n is 12. So what we're basically saying, if you wanted to use this rule now to find the 10th term, we would do 3 times 10, because n is 10 for the 10th term, and then we would take away 1. So 30 take away 1, 29. So that's one of the uses of the rule. You can use it to find whatever term of the sequence you want. We can check if we've done it right by checking, say, right, what would the 3rd term be? So 3 times 3, take away 1 is 8. And if we go back up to our sequence, yes, the 3rd term was 8. So you can always check if you're doing it correctly by checking if you can get one of the terms you already know. After you do enough of these, it becomes quite easy. So let's say we had a different sequence. What we should be looking at is what's it going up in. It's going up 5 each time, just like the 5 times table. How do we write that? We write 5n. How do you then figure out, there tends to be like we add something on or take something off. So there's a couple of ways of doing that. What you can do is write the 5 times table above and then think, how do I get from 5 to 7? Well, we subtract 2. And that works for each of those. Oh, we add 2. 10 add 2, 12. So our rule is 5n plus 2. It's the 5 times table with 2 added on. Again, if we wanted to check whether we've done it right, we could check the 3rd term again. 5 times 3 is 15, plus 2 does give us 17, so it works. Now, there is another way of finding this plus 2. What you can do is think about a hidden number at the start. What would have come before 7? What's the number that would have been there? Well, because we're adding 5 as we go up, we would take away 5. 7 take away 5 is 2, plus 2. So our rule is 5n plus 2. Let's try that way for the next one. So say we got the sequence minus 1, 3, 7, 11. This is a linear sequence. This is what we're doing in this video, which means the differences will always be the same. In this case, they're 4, just like the 4 times table. So we're going to write 4n. If I imagine there being a number there, what would that number be? It's the same number as I'm going to put here in a minute. Well, for minus 1 take away 4, because we're going the other way, is minus 5. So our rule is 4n minus 5. Okay, again, I've used the 3rd term each time. Let's check the 3rd term again. 4 times 3 is 12. Take away 5 is 7. It works. Never check the 1st term because you can have the wrong rule and it can still work. So the use of this is we can now use it to find, say, the 100th term. We would do 4 times 100, which is 400, take away 5. So the 100th term of this sequence would be 395. We could also use it to check whether a number's in the sequence. So if someone said to me, is 277 in the sequence? Well, I can say 4n minus 5, can it ever equal 277? So we would solve this linear equation. We would add on 5 to get 282. And then to find n, we would divide 282 by 4. And we get 70.5. Now, n needs to be a whole number. It has to be an integer, the maths word for that. So if we're getting 70.5 here, then 277 is not in the sequence. So that's another use for it. Hopefully I explained that well for you. I've got a worksheet which you can have a look at. It's available in the description if you want to download it for free. There's also the solutions there. Hope that was helpful.